On number 2, we are to solve algebraically and then support our answer numerically and identify extraneous solutions. Big tip here, anytime you multiply through by any factor containing x, you always need to check your solutions because you frequently bring in what's called an extraneous solution because it algebraically works in your process but fails to work when it's substituted back in. So here we go. The first step here is to get rid of the x in the denominator. So we do that by multiplying by x. If we multiply that by x, we have to multiply the left side by x, and then that gives us x squared plus 2x equals 15. So then we bring everything to one side because it's quadratic, and our highest hope is that it will factor, and this one will. So we need the factor pair that multiplies to 15 with a difference, because the 15 is subtracted, of 2, which would be 5 and 3. Well, that gives us negative 5 and positive 3 as our candidates for answers. So we substitute these back into the original function, and if we plug negative 5 back into the original equation, I called it a function, that was an equation, negative 5 plus 2 equals, and you're really asking yourself if this is true, so you can put a little floating question mark there to say, I'm not saying this is true, I'm asking. And then when we plug negative 5 into the other side, this is what it looks like. Well, the left side gives us negative 3, and the right side gives us negative 3. So we have just verified that negative 5 is a solution. We do the same for our positive 3 that we got, and we replace x with 3. And we again write, is 3 plus 2 equal to 15 divided by 3? Well, the left side gives me 5, and the right side gives me 5. So this one also works. So that verifies that both of the solutions we found through our process get to be recorded as the answers, and there are no extraneous solutions for this one. Now let's look at number 12. Clearly a little more involved. Well, anytime you see that you have a denominator that can be factored, that should be your first step because that will help you figure out what your least common denominator is. And in this one, we can factor the denominator on the right side into x times x plus 4, which works out nicely because one of our terms on the left already has one of those factors as its denominator. But this becomes our LCD. So we're going to distribute that, or not distribute it, we're going to multiply both sides by our LCD, which would be x times x plus 4 times 2 minus 3 over x plus 4. And then, of course, what we do on one side, we must do on the other. So since the 12 has our LCD as its denominator, we're going to completely get rid of the denominator on the left by multiplying by our LCD of x times x plus 4. So we can go ahead and slash that as soon as we write it. And I know that seems silly, but at least that shows where the next step came from. Since 2 has 1 as its denominator, it has nothing to cancel either of the factors, so we're going to have 2x squared. I'm just going to multiply it all back together again, plus 8x, because it would be 2 times 4 times x there. And then we multiply our LCD times 3 over x plus 4, and remember that was minus. Well, the x plus 4's cancel for this term, so that's just minus 3x equals the 12 that we had left on the other side. Let me make that 2 a little better. Alright, so now we have to solve this equation. It's quadratic. We're going to move all the terms to one side and hope it's factorable, and this 2 is factorable. So we have 2x squared plus 5x minus 12 equals 0. So we set up our factor candidates, and remember, if we put a 2x in both spots, the third term is subtracted, means we have one of each sign, and we multiply the 2 and the 12 together to get the factor pairs for 24, and we need the pair that multiplies to 24 with a difference of 5. Well, that's pretty simple. That's 8 and 3, so the big one goes with the sign of the middle term. Can't reduce the second factor, but I can reduce the first factor to x plus 4. So this is x plus 4 times 2x minus 3 equals 0. Once again, negative 4 comes out as a solution, and 3/2 comes out as a solution. We get 2 zeros to check, but we must check both of them. And it's easier if you check them using the factored form. If you take the time to check these, you can use your store feature on your calculator, because these are calculator allowed questions. In case you're worried, the test examples like this will be more easily substituted. It won't be quite as ugly values as we're dealing with here. So feel free to pause the video, use your calculator to check these solutions. What you should find is that the -4 is extraneous. It does not make the equation true. And a quick look back, if you look at what happens when we plug -4 into the original, you're going to get a 0 in the denominator. And as soon as that happens, you can stop. It's extraneous. It clearly did not work. But 3/2 does work. So we get one solution for this one, and that is x equals 3/2. Number 14. Again, the very first step should always be, when you have an unfactored denominator, is to factor that denominator, because that will in all likelihood be your LCD. This one factors to x plus 4 times x minus 1. So that is our LCD. So we're going to multiply both sides by it. So x plus 4 times x minus 1 times 4x over x plus 4 plus 3 over x minus 1. And that is a giant typo on the packet, by the way. That should be a plus there. So make sure you got that fixed on your paper. I tried to do this problem 3 times and it wouldn't solve out, and then I realized what I had done. Alright, this is 15 over my LCD, x plus 4 times x minus, and that looks like 11, but that's a parenthesis, believe it or not, x minus 1. And then again, this side has to get multiplied by the same thing. And those cancel, so I'm going to be left with just 15 on the right. And then when we distribute this LCD across the left side, for the first term, the x plus 4 will go away and leave me 4x times x minus 1. For the second one, the x minus 1 will cancel, and I'll be left with plus 3 times x plus 4. And remember, the only thing we had left on the right was the 15. So then we have, when we distribute everything out, we have 4x squared minus 4x plus 3x plus 12, and we're going to bring that 15 over all in this step. So that would be minus 15 equals 0. And we get 4x squared minus x minus 3 equals 0. And we set up our factor pairs again with the 4x in the first spot of each. And the 3 is subtracted, so I have to have one of each. And I need the pair of numbers that multiplies to 12, because remember, when there's a coefficient, you multiply the constant by the leading coefficient to get the number you're looking for. So I need the factor pair that multiplies to 12 with a difference of 1. Again, really simple. That's 4 and 3. Can't reduce this factor, but I can take out a 4 here to get rid of the 4 I brought in. So my two solutions are negative 3/4 and 1. And again, feel free to use your calculator here. What you will discover is that the negative 3/4 works. This one does not. So for your final answer, you should write x equals 1. And that is our only solution because, or nope, I said that backwards, didn't I? Sorry. Let's try that again. We'll pretend like that didn't happen. X equals negative 3/4 because the 1 was extraneous. So we do not include it in our answer. And that is all the examples for 2-7.